Good day, viewers all over the world. Today, you are welcome to a fun physics class with Teacher Oge, where we shall be talking about the topic dimension. Again, dimension. What are dimensions? Dimensions are measurable properties that describe the physical state of a body. Again, they are measurable properties that describes the physical state of a body. Okay, let me relate it to real life. Looking at this brush here, immediately you look at it, you will be looking at seeing that there is a blue color used in making this. There is a wood used in making this. Now the color, the wood, and the brush particles used for making this describe the physical state of the brush. Now we come back to physics. Dimension will tell us the physical state. In other words, the nature of the fundamental or basic quantities that are contained in a given body. For instance, I talk about velocity. It's dimension that will tell me the basic quantities that are coined up to make velocity. When I talk about force, dimensions will tell me the basic quantities, the physical quantities that are contained in making force. Now, before we move ahead, let's remind ourselves of the 7 fundamental quantities and their dimension. The first one is mass, and the dimension is m, length L, time T, temperature theta, it is pronounced theta, electric current I, amount of substance N, and luminous intensity J. These are the dimensions of the 7 basic quantities. All right, let's see how to get dimensions of other physical quantities. Let me start with volume. Volume consists of length times breadth times height, which is length times length times length, and the dimension of volume is going to be L cubed. Then velocity, which is given as the rate of change of displacement, that is displacement over time. Now, what is the dimension for displacement? Just like length, it is L. And what is the dimension for time? It is T. Now, when we bring them together, we'll see that velocity has a dimension of L, T raised to power minus 1, or length per time. Then acceleration. Acceleration is the increase in the velocity of a body with time. That is velocity over time. Now, what is the dimension for velocity? Already obtained, length per time, then divided by time. And this will be giving us length per time, then divided by time raised to power 1. By law of indices, this becomes LT minus 1, then because of division, minus 1, and this shall be giving us LT minus 2. And that is the dimension for acceleration. Now we talk about force. Of course, force is given as the product of mass and the acceleration. And what is the SI unit of the dimension of mass? Still m. And then, what is the dimension of acceleration? Because we've already obtained that, and that is length per time squared. And this together will be giving us MLT minus 2. So the dimension for force is mass, length per time squared. This is the dimension of the following quantities. All right, I shall be giving us or leaving us with some tasks. derive the dimension of the following. We have pressure, we have momentum. Okay, do that and let me see your answer in the comment section. Thank you.